Okay, let's come to probably, I think, the most significant part of estimating square roots. Here, we want to estimate not just between what number or what number is close to, but pretty much to the nearest tenth or to the nearest hundred. Again, keep in mind we want to use those perfect squares that we created to approximate the square root of the value of the non-perfect square. So let's take one example. The first example says a room is measured at 200 square feet and we want to find the side length. So we have some steps involved. First step says we need to find the value of the whole number. What I mean by that is we want to be able to find the two perfect squares that 200 falls between. So we want to find the two perfect squares that the square root of 200 fall between. Now, the reason why we're saying that is because we're looking at our perfect square list and we see that 200 is not a perfect square. But as we look at the list, we see that 196 is there, and 196 happens to be less than 200. And we also see to the right of 196, we see 225. So what we want to do is we want to take the square root of 196, find that integer, the square root of 225, and find that integer. Okay, so I'm going to draw a little number line here, and I know this will give me 14, and 225 integer is 15. So I'm going to put a half point mark here which says 14.5, and what I'm looking for is the square root of 200. Now, what I need to do, and recall from the last video, is we need to find the distance. So I'm going to take 200 and subtract 196, and I'll get 4. Then I'm going to take 225 and subtract 200, and I'll get 25. So this is telling me that my actual square root of 200 falls within this area because it's closer to 14 than it is to 15. But now here's a concept that I want to throw in here for step 2, and that is to find the value of the decimal. So we want to be able to, once we get 4 and 25, let's find the value of the decimal. And I think this concept here will maybe relieve some of the why are you choosing these particular numbers. Now, when I look for the value of the decimal, I'm looking for the difference between the given what am I looking for? Between the given 200 and the lower number. Okay, so here I will have 200 minus the lower of the perfect squares is 196, and that will give me 4. We just did that up there. Now I want to find the difference between the greater perfect square and the lower perfect square. So my greatest perfect square is 225, and my lower perfect square is 196. So I'm going to subtract 225 minus 196, and that is a 6, so that'll be 1, then that's going to be 1. Actually, that will give me 11, and this will give me 15. So 196, and 15 will give me 9, and 2 from 11 will give me 2. So I see that the difference between the greater perfect square and the lower perfect square is 29 here. Now I want to write these as a ratio. So if I write these values as a ratio, so let me put 3, I want to write as a ratio. So if I write as a ratio, I'm going to get 4 over 29. And of course we all know that that just means 4 divided by 29, or 29 divided into 4. Okay, decimal here. I definitely know that it's not going to go 0 times, and then I will put a 0 here. That's going to go 1 time, and then that's 29, and I should have 11, and I'll drop another 0, and that will go 3 times. 3 times 9 is 18, and 3 times 2 is, let's see, 6. 1 is 7. So here I'll have 2 and 2, and here 0, and we'll say probably 8 times. So what I have is roughly 0.13. Since we want to look at it, round it into 10th, let's just round this up looking at the 10th value, and we'll call it 0.1. Okay, so now to find my value, I will take my distance, which is 14. It's closer to 14, so I will take 14 plus 0.14, because I round that to approximately 0.14 because of the 8, and that will give me 14.14, and they asked us to round to the nearest 10th, and that's going to give me 14.1. So as you see, pretty much the same thing that we have here when we guessed, but this is a more concrete way of doing it. Then that way you can see a little bit more work, but a little bit more concrete work. So again, we're looking at the approximate value is 14.1. So make sure that you understand when we added one step, we looked at the difference between the two, which was 4, and then we looked at the difference between the two actual perfect squares, and we got 29, and then we divided, wrote as a ratio and divided, and then we were able to add and come up with 14.1. But we'll work a couple more problems and make sure you get a good concept of this, and then we'll move on.